Okay, let's try another example. This one's a little more complicated, and it involves a common trick for these types of integrals. So suppose I want to find the arc length of the curve y equals e to the x plus e to the minus x over 2 between x equals 0 and x equals 2. Well, the a is 0 and the b is 2, and I need to calculate f prime of x and its square in order to find this arc length. The derivative is 1/2 e to the x minus e to the minus x, and its square is 1/4 times e to the x squared, which is e to the 2x, minus 2 times e to the x times e to the minus x, plus e to the minus x squared, which is e to the minus 2x. And now this middle term, 2 times e to the x times e to the minus x, is just 2 times 1, because e to the x times e to the minus x is e to the x minus x, which is e to the 0, which is 1. So f prime of x squared is e to the 2x over 4 minus 1/2 plus e to the minus 2x over 4. And now popping that into the arc length formula, I get the arc length is the integral from 0 to 2 of the square root of 1 plus e to the 2x over 4 minus 1/2 plus e to the minus 2x over 4. And of course 1 minus 1/2 is plus 1/2, so that whole thing becomes e to the 2x over 4 plus 1/2 plus e to the minus 2x over 4. And notice that this is just e to the x over 2 plus e to the minus x over 2 squared. And the pattern here that I'm looking at is if I have two numbers, capital A and capital B, then 1 plus a minus b squared is a plus b squared if a times b is 1/4. In other words, if you have this cancellation thing going on in the center here, that 1 minus 1/2 becomes plus 1/2. Well, summarizing, we have our integral is the integral from 0 to 2 of the square root of e to the x plus e to the minus x over 2 squared, and the square root of anything squared is the absolute value of it, but this is a positive number, so this is the integral from 0 to 2 of e to the x plus e to the minus x over 2. And now we can easily integrate that. We pull out the 1/2, and the integral of e to the x is e to the x. The integral of e to the minus x is minus e to the minus x. And we end up with e squared minus 1/e squared over 2. Now this was a somewhat more difficult integral, and in general the integrals you get for arc length are quite difficult to solve.